our sample. The second and very important aspect of the quality of our sample is how representative it is. Does the composition of our sample reflect the composition of the general population? If our sample of Russian people includes only students from the higher school of economics, obviously it's not such a good idea to try and generalize to all Russians, because this sample is not representative. There will be some sample bias, and this sample bias might be very strong. So always, in every sample, you get some sampling error and you get some sample bias. The question is whether you can be sure how large your sample bias is and whether you can kind of control and adjust for this sample bias statistically. And this depends on how you recruit your sample. If we look at different sampling strategies, we can group them under two headings. Probability sampling, it's a situation when the character and the extent of your sampling error are completely predictable. They are determined by statistical laws, so you can be sure that your sample is a kind of more or less random sample from the general population, and you can kind of predict how your sample statistics will behave, and you can always evaluate correctly the chances of your conclusions being right or wrong with respect to the general population. You can always evaluate whether your generalization will be precise or not precise. And this type of sampling strategies are typically used in sociology and sometimes in educational research, because there people are interested in large populations, they're interested in the properties of some characteristics in whole countries, and generalization is extremely important. So probability sampling strategies are like strategies of a healthy person. And now for smoker strategies, or unhealthy sampling strategies that are called non-probability sampling. If you recruit people just using some kind of non-systematic approach, you just ask your friends to complete your questionnaires. The deviation of sample estimates from the true values in the population will be completely unpredictable. It will depend only on who your friends are. There is no way to quantify this deviation, and you can never be sure how the picture that you see in this sample compares to the picture in the whole population. Obviously, if we want to generalize, this is not a very good choice. This is not a very good sampling strategy. But such sampling strategies are fairly often used in psychology because getting a representative sample is probably too difficult, and because given how long our questionnaires are, so it would require too much resources, and also because our research questions, they don't always involve generalization, and they don't always involve an attempt to reconstruct the general population. So sometimes we are just interested in what we observe in a particular sample in many studies. But to take a look at different sampling strategies, let's explore them a little bit, and we'll start with probability sampling. Imagine that we have a population of people in a country, a very small country, where we have only 50 individuals living there. And they are blue, red, or green. Let's think of this as political party preferences. And obviously, if a population is so small, we could survey them all. But let's say for our purposes, we need to take a sample of just 10 individuals. What approach would you use? Obviously, the most intuitive approach is to do a true random sampling. Just sample them randomly. For example, if you have a list of all people living in this country, or a phone book where you have all the individual phones, you can just use a computer to select entries from that table randomly, or select every 10th person. This will be systematic random sampling. And then you'll get a list of people to survey. Using this approach, each unit in the population, each person in the population has an equal probability of being selected in your sample. So your sample is a completely random sample. Obviously, this approach does not guarantee that the sample will be representative. Imagine that in our country we have 25 men and 25 women. If we choose randomly 10 people, all 10 of them can be men, or all 10 of them can be women. Obviously, the chances of this happening are not very high. Usually you will get some men and some women in your sample, but almost never you will get an equal proportion. Although, on average, if you take samples, on average, proportion will be equal. But every particular sample can be quite different from the general population. So random sampling does not guarantee that your sample is representative, but it maximizes the chances of your sample being representative on most characteristics, even those you don't know about. But the main issue with this approach is that it is too difficult for large populations. For a small population, it's fine. For example, if I wanted to survey students of the Higher School of Economics, I would just get a list of all the students and randomly email my survey to them, no problem. But if you want to survey people from Russia, you don't have a whole list of individuals, and even if you could select them randomly, there is no way you could approach them all because they are living in different cities, in different locations. So with large populations, this approach does not really work well. And it also has a problem if you have some exotic type of individuals. You might not even get those individuals in your random sample. For example, in our country, we have only 20% of green individuals, 10 out of 50. But if we just randomly pick 10 individuals, and I did a random draw here, you see that there is no single green person in our sample. And based on this sample, maybe we could reach some biased conclusions about those green persons because we would not know what to say. But the main issue with true random sampling is that it only works for small populations. For larger populations, like Russia, for example, we typically use another approach which is called cluster sampling. We try to divide this population into clusters. For example, if we are interested in all Russian students, we take a look at the level of school, or in sociological surveys, they divide the city into quarters and they survey each quarter, each neighborhood separately. So when we do cluster sampling, we say, I will randomly select several clusters. For example, I want to survey children at schools in Moscow, and I will randomly select 5 schools in Moscow. As a result, each group will have an equal probability of being selected, but not each individual, because the composition of schools might be completely different. Some schools might be in very affluent, rich neighborhoods, and there are only children of rich parents, while other schools might be in poor neighborhoods, or there might be a larger proportion of migrants who don't really speak Russian language. So depending on how unequal is the distribution of individuals in different schools, you will get an increase in your sampling error. So cluster sampling always increases your sampling error. Sometimes it increases it hugely, but how much it increases depends on how diverse are the populations in different schools. If all the schools have the same proportion of children from different kind of groups, your sampling error will not really grow. But if you have a school in a rich neighborhood and a school where you only get children of migrants, you will get a lot of sampling error. How does cluster sampling work in practice? Very easy. I just try to draw groups of individuals in the same area. And as a result, my sample might be or might not be representative. But at least I can calculate this sampling error if I know the composition of different areas or of different schools, and I can estimate correctly my standard errors and make correct statistical inferences. But obviously, random sampling and cluster sampling is not always satisfying, because we really want to control the extent of our sample bias. This is why we use another approach, which is called stratification. When I use stratification, I divide the population into strata or into groups against which I want to get representative sample. For example, males and females, or in our population, blue, red, and green individuals. And then I randomly sample units from each group. So I randomly recruit a certain proportion of blue, red, and green individuals, or a certain proportion of males and females. And if this selection is random, this is called stratified random sampling, and it's also a good probability sampling approach, which reduces sampling error compared to cluster sampling and even to random sampling. Unfortunately, what's really important here is that the procedure of selection and the approach to selection of individuals within different strata should be exactly the same. And this is what sociologists use when they recruit a certain number of individuals of different genders and different age groups. They recruit them all in the same location at the same time. And that's how they arrive at stratified random sample. In student research, we sometimes have this situation when a person has collected some kind of sample, which was fairly good, but there are not enough males, for example, because males are not likely to participate in psychological surveys, and this person is thinking, okay, I don't have enough males. Maybe I will try to ask my male friends to complete my questionnaire for me. And as a result, this completely screws up the sampling, because your male friends might be quite different from an average male in the population from which you sampled the original sample. As a result, it does not improve the quality of your sample, it only makes it worse. Because now the gender differences will be also related to some other differences, by which males in your sample are different from those in the general population. So don't use this approach. This can be called quota sampling, but it's non-probability sampling. It's not a very good idea. So when we do this stratified sampling, we say, okay, the proportion of blue, red, and green individuals in my population is 50, 30, and 20% respectively. I will aim to recruit a sample where the proportion of blue, red, and green individuals will be the same. So for example, 50% of 5 blue individuals, 3 red individuals, and 2 green individuals. As a result, you can make generalizations to the general population, and you can be confident that your generalizations will be precise because your sample is representative against color. But you don't know about whether it's representative against other characteristics which we don't know about. And sometimes we use a slightly tricky approach, which is called disproportionate stratification. Why do we use it? Because if you have, for example, in your sample, imagine that those are schools. You have 5 public schools, 3 high-achieving schools, and 2 private schools. And you want to compare the scores across different schools. But you only have 2 private schools, and this is not enough. To get a meaningful comparison between different types of schools, you need to have an approximately equal and sufficiently large number of each type. This is why when we do stratified samples, sometimes we oversample. We oversample very small and exotic groups in order to be able to arrive at a more precise estimate of our statistic for this small group. And if during the sampling procedure researchers used this approach, if they oversampled, if they used this disproportionate stratification, as a result, you get a situation where you need to use weight coefficients in order to calculate correct estimates for the general population. So imagine you have 90 public and 10 private schools in your city, and you want to choose 10 schools for your study. If you did a proportional stratification, you would choose 9 public schools and only 1 private school. But obviously 1 private school is not enough for your conclusions. If you want your conclusions to be equally precise for public and private schools, maybe you will choose randomly 5 public and 5 private schools. But as a result, for 90 schools in the population, you get 5 schools in your sample. So each public school in your sample represents 18 schools in the population. And each private school in your sample represents 2 schools in your population, because you sampled 5 and there are 10 altogether. As a result, for each public and for each private school, you have this weight coefficient, 18 and 2. And this is basically the coefficient that you need to use when you calculate the mean score for the general population. Normally, these weight coefficients are rescaled so that they all together equal 1. But when you use some data from large-scale surveys, for example, PISA or PIRLS or TIMSS, very often you get a variable which is called weight. If you're just interested in the level of individuals, maybe this weight variable is not important. But if you want to arrive at a correct estimate for the population, you need to apply this weight variable in SPSS, which will adjust for the disproportion of this particular type of individual in your sample compared to the general population. This is, of course, a bit of advanced sampling. I will not go into details here because there are different ways you can calculate and scale those weights, but at least you have an idea of what those weights are. So if you encounter this variable, you'll at least have an idea of what it is about and how to use it. In this situation, when you have weights and sometimes maybe you have different strategies used at the different sampling stages, it's called a complex sample. A complex sample where you need to use this weighting in order to arrive at correct estimates for the country as a whole, for example. And of course, in order to apply those weights correctly, you need to know about the sampling strategy and you need to know what those variables are. So you need to read the manual that comes with this data set. Of course, it is only used in very large studies where people spend millions of dollars to organize this whole effort to data collection. Unluckily, in our student research projects, we don't really have the opportunity to spend $1 million collecting a very large and representative sample. Unfortunately, in real life, we use different sampling strategies. For example, we ask our friends or colleagues to complete our questionnaires, like on this picture. And these are the unhealthy sampling strategies. They are kind of unhealthy, but still we use them quite often in our research. What are those sampling strategies? The first one is called purposive sampling, when you know exactly what kind of individuals you need for your research, but it's impossible to define a general population. Imagine that you're interested in some very exotic group of people. For example, pregnant women who take cocaine, and you want to do an interview to find out how do they deal with this whole issue, their attitudes, and so on. There is no list of pregnant women who take cocaine. There is no way to know how large the population is and how you should sample. So the only approach you can take here is to just start searching for these individuals and recruiting them in your sample. This is called purposive sampling, and it is often used in qualitative studies. Another approach that we use very often in our quantitative studies, when you only have 3 days for your data collection because you need to write up your master's dissertation, you can always use the good old snowball approach. You post a link to your questionnaire on your social network page, and you ask your friends, if they are really your friends, to please do a repost on their own pages. And this way, your sample starts growing very quickly like a snowball. But unfortunately, it grows completely unpredictably. You have no way to tell whether people in this snowball sample are different or not different from the general population. And sometimes this difference is absolutely drastic. In our studies with Olga Gulevich, a social psychologist, we focused on homophobia, and we did a snowball sample of individuals on Facebook. So Russian individuals on Facebook who agree to participate in a study on homophobia, they are extremely tolerant. And if we compare to the general population, we see that this sample is completely skewed. As a result, we had to also do some paper-based samples in more realistic groups. Even students of the higher School of Economics turned out to be much more homophobic than an average social network user recruited using snowball approach. And obviously, students of the higher School of Economics are much more tolerant than the general Russian population if we look at surveys. So be careful about snowball approach. A convenience sample. Just use a group of people that you can easily approach. For example, if I were giving this study in a room where you were present, I could just hand out my nice questionnaires to you and say, oh, dear friends, could you please complete my wonderful questionnaire? And as a result, I would get a convenience sample, but it would be completely unpredictable. Again, how it differs from the general population depends on what this convenience sample is. And finally, there is the self-selecting sample. If you post an ad somewhere online or an ad somewhere at the department saying, could you please take part in my study? It's so interesting. And some people agree to take part in your study, but those people are volunteers. Obviously, all the studies that we do are supposed to be done with volunteers. But if you ask people to actually make an effort to participate in your study, you get real volunteers who are going to go out of their way to contribute to your research. And this group of people will be somewhat different from the general population as well. This has been studied for a long time in American psychology, and many researchers found that people who tend to volunteer for research studies, they are different from the general population. They have a higher education level. They know what research is about and why it's important, which motivates them to take part. But also they have a higher social status. They have more money, and as a result, they have time to devote to some strange questionnaires. Whereas people with lower social status, they spend all the time just earning money and they have no time to participate in research studies. Volunteers tend to have higher IQ. They tend to have a higher approval motivation. These are the people who want to help others and they want others to recognize them as nice people. And also people who volunteer for research studies are more likely to be female. At least in Russia, it happens very often. It's harder to find male participants than female participants. So very often in our online studies, the proportion of males to females is like 25 to 75, and sometimes it's even worse. So the only way to solve this is to get more people if you want to compare males and females. But of course, this volunteer bias is not the only type of bias that you can encounter. And the good news is that you can actually manipulate this bias by manipulating the motivation of people to participate in your study. The classical approach is when you say, oh, dear friends, could you please help the science, produces a volunteer bias because in order to participate in your study, people this is based on altruistic motivation. But you can also create a situation of a competition, for example. Those who have the highest scores on my IQ test will be posted somewhere online or will get special badges. This kind of primes achievement motivation. For ability tests, it is important because it is important if we want to get a true estimate of ability that people actually make an effort to do their best on these tests. In a selection situation, for example, you survey a bunch of people who are applying for a job or who are applying for some kind of a university position, you will get very strong approval motivation and achievement motivation. People will be likely to give you profiles that kind of correspond to expectations of those who organize the competition. So doing research in such a situation is a bit challenging. You need to do it very carefully. Or another approach is to use a monetary reward. You can say, for example, every person who participates in my study will get $1. But obviously, very often you don't have much money to do it. So what we do is, for example, you do a prize draw and you say 3 people who will be randomly selected from all the participants in this study will get a book voucher for $30 that they can spend on Amazon. And this also creates an incentive for people with materialistic motivation to participate in your study, and this reduces to some extent the volunteer bias. Or you can promise people some feedback on this course. And as a result, people will be likely to give you true information about themselves. They'll be very open because this will be based on their motivation for self-understanding. But of course, with feedback, you need to be very careful. First of all, it takes a lot of effort to do it. And second, when you write your feedback, you need always to think of a person who is on the verge of committing suicide. So try to write your feedback in such a way that even if a person is standing on this bench and are ready to jump down, they will not do it. Your feedback needs to be very carefully phrased, because when people have the opportunity to make wrong conclusions, be sure that some people will do it. That's why it's probably best not to use feedback in most situations, or just to give feedback on very harmless psychological variables. But the good news is that you can recruit different types of individuals and reduce the volunteer bias by addressing different types of motivation. So to conclude a little bit on sampling strategies, there are 2 types of sampling strategies. The good sampling strategies, or the sampling strategies that we would love to use if we had a lot of money and a lot of time, and these are probability sampling strategies. The advantage is that the extent of your sampling error and the character of your sampling error are predictable. So you can generalize to general populations, and you can always evaluate the confidence of your generalization. You can evaluate the confidence interval, and you can be sure that the true score for the general population is somewhere within this confidence interval. Unfortunately, it takes too much resources. So these probability sampling strategies must be used when your research question concerns the general population. If you want to make some conclusions about countries, it's best to use a probability sampling, and instead of collecting your own sample, maybe it's best to use World Values Survey or European Social Survey, where people spent a lot of time and a lot of money to actually come up with this wonderful data. But in our studies, we usually use non-probability sampling, when the deviations of our sample estimates from true population values are rather unpredictable. The disadvantage is you cannot really generalize to populations. You cannot really make a conclusion about Russian people based on a bunch of students from the Higher School of Economics who completed your questionnaire. But in psychology, this approach is used very often because our research methods are often very time-consuming and take a lot of effort from our participants, so it would be too hard to get a large sample. And also, generalization to populations is less important in psychology than it is in sociology or in educational research. In psychology, we are often interested in the associations between individual differences or the effects of manipulations on some kind of outcomes. So if you are conducting an experimental study, for example, maybe your size of your effect will change a little bit depending on the social group. But in most cases, we assume that it should not really change drastically. And this assumption is based on experience of conducting research studies. So if you assume that the phenomenon should not really vary very much in the population, you can even use a small and non-probability sample. That's why when people do MRI studies or some kind of attention studies, they use typically samples like 20 students of the Higher School of Economics, all female, because basically perception is pretty much the same regardless of who it is, male or female, rich or poor. But that's not true with respect to many socioeconomic processes. That's why the choice between different sampling strategy depends on your research question. And if you come up with some kind of a sampling strategy, or you're evaluating someone else's study, there are 3 questions or 4 questions that you need to ask. First of all, is the sample size sufficient? Is it sufficient to make precise conclusions? And this is where the issue of statistical power comes in, which we will learn how to calculate very soon. But the second question, what is the sampling strategy? Is the sample representative? And do you really need a representative sample for this particular research question? If the sample is not representative, if it is biased, in what way it is biased, and how should the conclusions be adjusted to kind of allow for this bias? And finally, if you are interested in some exotic, very small groups, does the composition of this sample allow you to make comparisons between those subgroups? Do you have sufficient statistical power to make such conclusions? Because maybe you want to compare people like males and females, but the number of males in your sample is so small that it's really hard to make good conclusions. So these are the questions that you ask when you evaluate your own or other people's samples. When you write a review of a research paper, this will be one part of it. And there are different ways to arrive at good samples. Right now, we will talk about one research approach that is very important nowadays: the online research. Why do we